Let's talk about the signed and unsigned versions of the data types. Now if we look here, you can see that I have a capital U here in parentheses around the int16, 32, and 64 as well as the byte. Now what this signals is an unsigned version and also an int16 version, which is a different version. The unsigned and the signed versions of those. Now what does that mean? Well, if we take a look at the bytes, for example, .NET base types of system, sbyte, and system.byte. These are unsigned and signed 8-bit integers. So these represent a byte. So for the signed integer, this is going to mean that we can have a negative value, minus 128 to 127. So if you need to represent a variable or variables within your programs, and you know that when you're using this particular variable, as you use it within the program, you're going to know that if you need values that are between negative 128 and 127, then you can use sbyte. That's how you're going to determine that, because you're looking at how big you want your memory to be. How much memory do you want to consume? And if you can get away with working with bytes instead of integers or shorts, then overall, as your program grows, you're going to save more memory when you're using the smaller data types. And if you know that you can represent something within the signed byte, then you can go ahead and use signed bytes. But don't make things over difficult for yourself. If a byte is going to represent something for you, then work with a byte. So moving forward, if we go into shorts, we're going to be dealing with a much higher range. As you can see here, 32,000. If you need something within that range, then use the int 16, which is a signed int. Just doesn't have an S there. The unsigned now, this is going to be the value from 0 to 65,535. So there are 65,536 values. Here there are 256 values. The same 256 values here, and the same 65,536 values here, only these go into negative values. So instead of starting at 0, it starts at the negative value there, and it crosses 0 and then goes up. So that's all that is to working with the unsigned and signed. Same thing with int. We're just getting higher. Now we're going from 8 to 16 to 32 bits, and we have a lot more room there. So if we need integers, we need values that are this high in this range, then go ahead and use ints. Ints are going to use a certain amount within our memory, and it's a lot easier to work with ints overall because a lot of the variables that we're dealing with are going to be 32-bit in nature. But shorts are also popular, especially when you're dealing with databases. Bytes and shorts are very popular, but go ahead and use all three. I recommend just using them as much as you need to. If you need a lot more and you're going to take up more memory, you're going to work with longs and ulong, the unsigned and signed 64-bit numbers. And then we have char, which is an unsigned 16-bit integer. It holds integer values, but it represents Unicode, and that goes from 0 to 65,535, just like an unsigned short. Except this is going to hold character data, represented as numbers.